Hello class. In this video we go over finding measures of variation, which is spread, using a TI-84 calculator. So for our first example here, it says to find both the population and the sample variance and standard deviation and find the range of the following data set. So if you watch the previous video that we did over central tendency, this is the same data set. A lot of this I already have in the calculator in the table, which is nice. We'll just see there's just a couple of extra keys that we need to hit to get the standard deviation and the variance and range. Also, we're just going to review how to do it by hand before we look at the calculator. So our first task was to find the population standard deviation and then the population variance. Now, if you remember, when we look for the standard deviation, we actually need the mean in our calculation. This is very small here, so I'm going to zoom in. But notice the population standard deviation sigma, that's the Greek letter sigma right there, it's equal to the square root of, we have the sum of every x value that we have in our data set minus the mean. So notice here for the mean instead of x bar, since it's a population, we're using mu. Or if you want to see it a little bit bigger, it's right here, mu. So this is sigma, which is what we're calculating here. And then we need mu, the population mean, to be able to do our calculation. So it's the sum of the difference of every x value and the mean, the population mean, squared, okay? And then we divide that by n, which is the total number of data points. And like I said a second ago, we're going to take the square root of all of that. So one thing to keep in mind for this set of data, the population mean and the sample mean are the same. So if you watch the previous video, we calculated the sample mean and got 10.7 just by adding all these values together and dividing by 20, because that's what n is. We have 20 data points. And this was the calculation that we did for that. Okay, so the sample mean was 10.7, but in this case, the sample mean and the population mean are the same. It's just 20 data points. So by hand, this is how we do that calculation. Now, if you notice what I did here, this is how I input the information for my data points. Notice that 7 occurs with a frequency of 3 times. So instead of writing 7 minus 10.7, right, 7 minus mu, the mean, 3 times and squaring it, what I did was I just multiplied it by 3. And then we did that, the same thing, 1 occurred with a frequency of 3, so I put that in there too, the difference between 1 and 10.7 squared times 3, and so on with all the different data points. And dividing by 20, when you do all that calculation and put that into your calculator, you're going to get approximately 9.333 if you round to 3 decimal places. And then the variance is just the standard deviation squared. So in other words, we just don't take the square root that we did in this formula. Okay, and that'll give us the variance. If you already have the standard deviation, then you would have to square it. And so we get 87.105. That's our variance. Now just real briefly, let's talk about what standard deviation and variance are. So we said that they are a measure of spread. So standard deviation is just one of our measures of spread. It's exactly what it says. Standard is kind of like the typical or the average amount, right? And then deviation means how much does it deviate from? How much does it vary from a certain amount? So when we talk about standard deviation, we're looking to see how much each of our data points varies, or how far away, how much does each data point deviate from the mean. So for the population standard deviation, how much does each data point deviate from the population mean? And we put that all together and we get that standard deviation. Now, sometimes it's more useful to square that value, and that's where we get the population variance. But those both are used to describe the spread of our data. Of course, the smaller the population standard deviation is, the more confident we can be that our population mean is a good measure of center of our data. Likewise with the variance. Now let's look at the sample standard deviation and sample variance. Notice the difference that we have on the formula with the sample standard deviation. We use S instead of sigma. Sigma is used for population. We use those Greek letters for the population. And then in the formula, notice it's the difference between every data point and the sample mean, which again, like I said, in this case is the same as population mean. We only have n equals 20 data points. But that's a difference that we have there in our formula. This no longer says mu, which would be the population mean, but it says sample mean, x bar. Also, on the bottom down here, it's no longer n, like we had over here. You can actually, like I had to zoom in on it earlier for you, but n appears at the bottom of our formula for the population standard deviation. See? See? Whereas n minus 1 appears in the denominator of our fraction for the sample standard deviation. Now, the reason that is, it kind of gives us, it's called the degree of freedom. So we have a degree of freedom of 1 there. That gives us, since our sample is used to approximate the population, it kind of gives us a little bit of a leeway for that fudge factor, for it maybe not being exactly the amount, but being an approximation. So we put n minus 1 on there. Another thing to keep in mind, if it's n minus 1, that means that this number is going to be smaller. Like for our example here, if n was 20, then this is going to be 19. Anytime you take a number, a fraction, and you've got a smaller number on the bottom, like for example, let's say I have 1/4, okay, that's 0.25. Well, that's actually less than 1/3, right? This is 0.25, this is 0.33333, it just keeps on going, right? The point is that 0.25 is less than 0.33333. I'll just put a little bar on that. But if you look at the fraction, we have a larger denominator here. We have the same numerator, larger denominator. And so we end up with a smaller number. So the larger denominator, if you have the same numerator, you're going to end up with a smaller overall number. So for our sample standard deviation, we have a smaller number on the bottom, which is going to make our sample standard deviation larger than our population standard deviation. And so whenever you're doing your calculations, if it's not, then there's something off in your calculations. So you always want to kind of make sure when you get your answers that they make sense. So if something's off, then you can fix it, right? Because especially in statistics, there's so many numbers involved, it's easy to like accidentally input something wrong. So this helps you to check that. But those are the main differences on the formulas. And then same thing with the sample variance. It's just going to be the sample standard deviation squared. So the shortcut is just don't take the square root when you're calculating the standard deviation, and that gives you the variance. So let's see. So if we do those by hand, this is what we have here. And we already looked at the formula a second ago, but once we input all of our information, we get the sample standard deviation of 9.576 approximately. That should be a larger number than the population standard deviation. Let's look at it. The population standard deviation is approximately 9.333, so that is smaller. So our answer makes sense. That's a good check. And then the variance, of course, is this standard deviation squared, 91.700 approximately, whereas the population variance should be smaller, and it is indeed smaller. It's approximately 87.105. So that's doing it by hand. And just let's just zoom in on this formula again. Look how huge this formula is. And that's even with consolidating some of this, like multiplying instead of writing out 7 minus 10.7, writing it out 3 times, right? So even with that, this is still a huge formula. And so I want to show you how the calculator is so much more useful in helping you to do your calculations faster. Of course, you need to know how to do this by hand. That's part of our course, is you're learning to do this all by hand. But it's good that you know how to use technology to help check your work. So let's look at the calculator. And so you'll want to go into Stat, and then you'll want to go to Edit. And I already input all that information into L1 for the previous video, and I left it there. The only thing is I did do a little command to have it sort it so that we could find the mode earlier. But even so, if it's out of order, it's still going to give you the same calculation. So this is the same set of data that we have here. Now, notice it's all in list 1. I go to Stat, and I go to Calc, 1 variable statistics, and make sure that list 1 is there. If it's not, then you have to do second 1 to get list 1, because notice it's there in blue. And that second, it's kind of like a little shift button for everything in blue, and that's why it's blue. All right, we push enter. There's no frequency list for this problem. And notice there's that mean that we used in our formula, 10.7. Even on the calculator, it doesn't give us mu. It doesn't say population mean, because for these, if we're entering them into a table, it's going to be the same population mean as it is the sample mean. Standard deviation, notice that it's approximately 9.576, which is what we got for that for our sample standard deviation, right? S. And the calculator does S sub x, and it's just showing that we're using the variable x. If we did 2 variable statistics, we could, at the same time, we could have, we could have data points, like ordered pairs, where we have x's and y's. In that case, if we did 2 variable statistics, we'd have 2 tables we're using, and we would have a standard deviation for y that would pop up, and we would have one for x. So that's all that little subscript of x means. And then notice here, this is the population standard deviation, sigma of x. Now that's 9.333, and that's what we saw earlier. This is the sample one. There we go. So this is the population one. This is the sample one. Notice the calculator doesn't give us the variance right out. For example, for the sample standard deviation, it gives us that value. We need to square that if we want to find the sample variance. For the population variance, it's also not listed. All we do is take the population standard deviation and square it, and then we'll get that population variance amount that we found by hand earlier. The last measure of spread that we were going to go over for that particular example is the range. The range is the maximum minus the minimum. If your data points are already put in order, either from ascending order or descending, you just look for the highest number, which is 32, and you subtract the lowest number, 1, and that'll give you 31. Now, if you don't already have it in order, the calculator, when we get that 5-number summary that we just did, notice that for that, it gives the minimum of 1, and it gives a maximum of 32. So we can definitely use the calculator to do that. Okay, but this is by hand, and then you see obviously it's a lot faster to use the calculator. Now let's look at finding the sample, standard deviation, and variance of group data. This example, it says to find the sample, standard deviation, and variance of the following data set of the number of hours of sleep a class of students gets per night. So we did see this data set in a previous video, but now we're going to go over how to measure the spread. So as a reminder, here is the formula for the sample standard deviation when we have group data. Notice the difference is that we take the sum of the distances between the data values and the mean, the sample mean, square them, but we multiply them by their frequencies. Okay, and then we still divide by n minus 1 for the sample. And then the variance, of course, is the same thing, just without the square root, because the variance is the standard deviation squared. So this is our standard deviation for our sample. This is our sample variance. So whenever we input these values, we can make a table to kind of organize this if we're doing it by hand. So first of all, in our formula, we're going to need x bar, which is the sample mean. So this just shows the calculation for the sample mean, which we saw in the previous video. So this is just a reminder of that. So for the sample mean, when it's group data, you take the sum of every data value x and multiply it by its frequency. Okay, so that's what we have there. We have the 200 when we add all those x times f. And then the sum of the frequencies is 34. So, and this is what it comes out to. And then you're going to need to input that into your standard deviation formula and your variance formula. So when we input all that in there, if you look, we're gonna need to do the sum of all of the deviations that we have right here, the distances of the x values from the mean squared. So in the table, here's those distances. Notice we have negative ones and positive ones, but when we square it, they all come out positive. And that's one of the reasons we square, is because sometimes this almost zeroes out. So we don't want that to happen. So we square it. And even if it doesn't happen, it still kind of doesn't represent the spread as accurately as if we were to square it and see it that way. So we square it, and then once you square all those distances of the x values from the mean, then you multiply them by their frequencies. Okay, so we do that, and that's what we get here. And then we're going to add up all of those together. So that's the sum. That's the numerator right there, the 125.529416. Then what we're going to do is divide by n minus 1. N is 34, so if we take away 1, it's 33. So we get approximately 1.950. If we want the variance, then we just wouldn't take the square root of that, and that's approximately 3.804. All right, that's doing it by hand. If you want to do it in the calculator, it's going to be a lot easier. Now, let's look at the population one. So the population, the only difference is, first of all, we have sigma here, mu for the population mean, which in this case there aren't many data points, so it's going to be the same as the sample mean. And then we're dividing by n instead of n minus 1. That's the only difference. So let's just look at the work for that. Okay. So I have 200 over 34 for the population mean. As I said, in this case, there's few data points. So it's going to be the same as the sample mean. And putting that into the formula, we're still going to get the same difference on our x values and the population mean multiplied by their frequencies, except the difference here is that we have Instead of n minus 1, we have n, so we have 34. So we have a larger number on the bottom, which means that for the population, this should be smaller. This is 1.921 versus the sample mean was 1.950, so it was larger because you're dividing by a smaller number. Comparing again, the sample variance was 3.804. Notice the population variance is approximately 3.692, so it is indeed larger. Okay, so let's look at the calculator now. For that set of data, I did use that in the previous video, so we should still have this information in here. Let's go to edit and okay, so notice these are the X values. I don't have their frequencies listed. I think I had to erase it to use this. So L4, I have the X values. Let's go ahead and put the frequencies here. Okay, for the frequencies, 0 has a frequency of 1. 1 has a frequency of 0. 2 has a frequency of 1. I'm just looking at the table that we're given. 3 has a frequency of 2. 4 has a frequency of 3. 5 has a frequency of 5. 6 has a frequency of 7. 7 has a frequency of 7. And 8 has a frequency of 8. And then what we'll do is we'll go back to stats. Stats, we're going to calculate. One variable statistics. Now, we had list 4 was where we put our data, and then list 6 was the frequency list. So notice the sample standard deviation is about 1.950, which is what we have here. And then we have to square it to get this. Now the calculator doesn't show us the variance like I told you. You have to actually manually square that. And the population standard deviation is about 1.921. And that's what we see we got when we did all these calculations here. So much easier to do it in the calculator, is it not? But of course you do need to know how to do it by hand, but please be able to check your work on the calculator. And then we want the variance we square. All right, for our last example, we're going to be estimating the sample standard deviation and variance of group data. It says to estimate the sample standard deviation and variance of this frequency distribution. We had this one in the previous video. And just, you know, it is a frequency distribution. We have them in classes, so we're not sure exactly. We know there's a frequency of 2. In this class, it goes from 1 to 11. We just don't know what numbers those are. It could be 4, it could be 8. We don't know. But it does occur with a frequency of 2. And then the midpoint, as a review, you just add 1, the lower class limit, plus the upper class limit, 11. That's 12. Divided by 2 gives us 6. If you need to see the last video as a reminder of that, please do so. In fact, I can pull it up real quick. So here's that little calculation you would do. So for our first midpoint, 1 plus 11 divided by 2 gives us 6. Okay. So when we're going to find the sample standard deviation, we use the same formula like we do for the frequency. It's just instead of every X value, we're going to use our midpoints as our X's. So those go there. And then, of course, the sample mean, and then n minus 1 is the normal. Take the square root, we get the sample standard deviation. If we don't take the square root, we get the variance. So the work for that, first of all, you need to get the sample mean. That was done in a previous video, but you take the sum of every X value, so every midpoint times the frequency in that class, divided by the sum of the frequencies. So when we did that, the sum of every midpoint times their class frequencies is 2471. And then the number is just going to be, the number of data points is just going to be the sum of the frequency. In this case, it's 36 when you add these up. We divide them, we get 68.638 with a little bar on top. Just means the 8 keeps repeating. We need that for our formula. When we plug it into our formula for the sample standard deviation, the distances of all those midpoints and that mean of 68.638 with a bar, times the frequencies of each class, that comes out to this big number that we have here, divided by n minus 1. If n is 36, n minus 1 is 35, that approximates to 23.492. If we don't take the square root, well, then that's just going to be the variance, which is the standard deviation squared. And that's approximately 551.894. Now, lastly, we're asked to find the population standard deviation and variance of the same group data. Notice the difference in our formula. We've got mu, which in this case is the same as the sample mean, x bar, but we're dividing by n instead of n minus 1. Everything else in our formula is the same. So here's the same mean that we had earlier. Okay, 68.638 with a bar. Except now we're labeling it as mu. And then the only difference here is that for sigma, we are dividing by n, 36. This number is the same up here. If you look back at the previous example for just the sample standard deviation, that number is the same. It's just this has a 35 because it's the sample. We're dividing by n minus 1 versus this one has a 36. We are dividing by a larger number here, which means our overall number is going to be smaller. That's expected for the population standard deviation. It's 23.161 versus 23.492. And of course, the population variance, sigma squared, is just the 23.164 squared that we see there. Now let's look at the calculator to see how we can more quickly do this instead of having to do all this by hand. So we're going to go to Stat, and we're going to go to Edit, and let's see, our midpoints. I don't believe I still have any of that. I'm going to go ahead and just start a new list. I'm going to clear all these out, in fact. Okay, so the midpoints are, let's see, 6, 17, 28, 39, 50, 61, 72, 83, and 94. And then we're going to put the frequency list in list 2. So we have 2, 0, 2, 1, 2, 6, 8, 8, and 7. And we quit out of there, and we're going to go back to Stat, and we're going to do Calculate. One variable statistics. Now I'm using list 1 and list 2 again. So L1, L2, enter. And so we can see that we have that sample mean, which is the same again as our population mean in this case. It's a small amount of data points. 68.638 with the bar, which is what we found earlier. Okay. And notice the sample standard deviation is 23.492 approximately. And that's what we found right here, but when we did it by hand. And of course, the calculator doesn't give us a variance. We need to square it manually to get that. And then sigma, the population standard deviation, which again, notice it's smaller than the sample one, it should be, is about 23.164. And we should see that from our calculations from it. And that's what we see. It's approximately 23.164. And then we can square that again to get the population variance. So of course, it's so much easier to do all of this with our calculator. It's a lot faster, but you do need to know how to do it by hand. Anyways, I just wanted you to see how you can use technology to check your work. And I hope you enjoyed this video. Thank you for watching.